This is our lesson number 35 in continuation with lesson 34, where we discuss the slow response action potential. Here we are going to discuss about the fast response action potential, and these are coming from atrial muscle action potential, ventricular muscle action potential, Purkinje cell action potential. So these three types are causing fast response. Fast response means you have seen in the SA node, the zero phase is slowly depolarizing. In this phase, these tissues, atrium, ventricular and Purkinje fiber, the depolarization zero phase is nearly vertical and it is fast to depolarize. Now let us come to the phases. In atrial muscle we had 3 phases. Here we have got 5 phases: 0, 1, 2, 3 and phase 4. Zero phase is known as phase of depolarization. Phase 1 is known as the P pointed phase between 0 and 2, that is phase 1, and this is early repolarization, due to early repolarization. And phase 2 is nearly flat and is longer, and this is known as plateau phase. So plateau phase is flat phase, nearly flat, and it is phase 2. Then comes the phase 3, that is repolarization, final phase, final repolarization. And phase 4 is now here flat, whereas in SA node, AV node, you have seen that there is a slope. Here it is flat, and it is because of the resting membrane potential. Back to resting membrane potential. So these tissues normally cannot initiate any rhythmicity. Then we come to the ionic basis of these phases. Zero phase is fast depolarization, due to fast depolarization. Why? Because there is a rapid entry of sodium through fast sodium channel. So if you see zero phase, there is rapid entry of sodium. Now then comes the phase 1. When rapid entry of sodium depolarization reaches a peak, then what happens? There is an inactivation of the sodium channel. Sodium channel is inactivated, that is, sodium is not going in, and there is potassium going out through potassium channel, So the phase 1 is because the sodium channel is closed, is closed, and potassium is going out, leaking out. So this is through the potassium channel. Then comes the phase 2. Phase 2 is known as plateau phase because it is flat. Here what happens? Calcium, which is a positive charge, is entering through L type of long lasting channel, calcium channel. So calcium is entering through L channel, and this is also called trigger calcium. And next thing is potassium going out. So calcium coming in, potassium going out, in nearly balancing. That's why there is a flat line or plateau phase. Then comes the phase 3. Phase 3 is inactivation of calcium channel. Calcium channel is inactivated, no calcium is going in, and there is outward efflux of potassium. The potassium is going out through potassium channel in phase 3. So phase 3 is the repolarization. One thing you should remember, with exception, that is, all depolarization is caused by sodium entry, and all repolarization is caused by the potassium going out, except in SA node where there is the zero phase, that is depolarization, is caused by calcium entry. Then there is a phase 4. Phase 4 is resting membrane potential. That means back to normal, and this is done with the help of sodium potassium ATPase pump, and potassium permeability will bring back everything to its original position. Now, what is threshold potential? Threshold potential is minus 70 millivolt. If you see in the diagram, minus 90 is the resting membrane potential. Then what happens? There is opening of sodium channel and sodium enters, or very little. When it reaches to 70, then there is a rapid entry of sodium. So threshold potential means when it is from minus 90, when it reaches to minus 70, because of progressively the negativity is reaching the threshold potential, and fast channel open at this time at minus 70. There is that leading to fast entry of sodium, causing rapid depolarization. So this is what is in the fast response. This is what is fast response action potential, 5 phases. Now another thing that here you should remember, what are the differences then? In atrium, the phase 2, the plateau phase is small, so duration of the potential is less than ventricular. And in Purkinje fiber, what you find, that the plateau phase is longer, that phase 2 is longer, so the duration of action potential is increased in Purkinje fiber. So these are the differences, otherwise shape will remain the same. Thank you.